Hi, I'm Larry Hahn. My brother Joe and I, we just finished framing this house. It's a one-story, 3-bedroom, 1,600 square foot house, and it's fairly typical of the kind of house that you'll find clear across the country. Now, normally speaking, it would take the two of us, plus a helper, 1 week to frame it. There's some reasons for that. It's not a real difficult house to build, but more importantly, we've broken the building process down to the very basics, and we work efficiently. And yet we're always careful not to sacrifice quality for speed. But the building of this house, it's been a lot different. We've been here a whole month. That's because we've had a video crew here recording what we've been doing step by step. We've had a camera looking in over our shoulder at every detail. The result of this is a series of videos on how to frame a house. And we're real hopeful that these videos, plus a companion book that I've written, will give you the kind of information that you need so you can build your own home. So here's a preview of what you're going to see on this tape. The first thing we do in this tape is check the foundation walls for square and parallel. Then we put the sills in place. Next come the posts, the girders, and then we can set our rim joists. Mark layout, roll and nail off the joists, and finally put down the sheathing. 2 extra sections of this tape deal with joisting over longer spans and how to build a set of stairs. You know, it's a good feeling. Come on a job, looks like this. It's clean, it's going to be a safe place to work. Any contractor that leaves a job looking like this has to be proud of their work. So we can be pretty sure that this foundation for the crawl space is square and level. And as carpenters, that's our responsibility to check that. Then we're going to put down our mud sill. If this gets done properly, the entire framing process is going to go a lot easier. So we'll begin by Joe and I checking this building for square. You pull out 6 foot, I'll pull out 8 foot. We're using a standard 6, 8, and 10 check to make sure the block layers left us with a 90-degree corner. Now if they didn't, we'll have to adjust the sill in or out a bit to compensate. Looks great, Joe. It's right on 10 foot. Let's check the diagonal, see if we're square clear across the building. This is your best check for the squareness of an entire building. What you're hoping for is that your diagonals are close to the same length. Right on the money. This building's square. Finally, we check the building for parallel. We want close to the same width on each end. 1/8 inch off, that's good. Some of these foundation bolts are bent. It's no problem. Take a hunk of 3/4 pipe and straighten them up. Well, it's time to scatter all of our 2x6 sill around the perimeter of the building. It's a treated sill, so it resists dry rot and it really discourages termites. And once all the sills are scattered, we can cut them to length. That's it. Looking good? So, time to cut all our sills. A good, efficient carpenter doesn't always have to use a measuring tape and a square to get the work done. Let's take a look how that goes. First of all, we sight down this concrete foundation. Get our board marked for length. We mark it with a saw cut. We pull the board out a bit. The next step is important. How do we cut square without a square? Well, simple. line the saw table up with the edge of the board and make the cut. Shove this piece of sill back out of the way and take a block of the same material and position it flush with the outside of the foundation. Then we can bring up this piece of sill and cut it to length again without using a measuring tape. Safety is part of being a good carpenter. Wear gloves when you're handling this treated wood, and wear safety glasses, earplugs, and keep that saw guard down. The next thing we do is mark the bolt hole locations on all the sills. Just align the board flush with the blocks. Okay, looking good. I'll mark the first one here. And then we just tap down with our hammer directly over each bolt. That leaves a mark that we can use for drilling our holes. We use a heavy-duty drill motor and a good sharp auger bit to drill our holes. We drill at least an 1/8 inch larger than the diameter of our bolts. To help keep out the cold, we put down a fiberglass sill sealer. You can also buy one that's made out of foam. Check your plans and the local code to see what's used in your area. Now the sills go down. Joe puts washers and nuts on the bolts, and I like to tighten them down with an impact wrench. That's a lot faster than a socket or crescent wrench. Yesterday, Joe and I finished bolting down all these mud sills. And you remember that we checked our corners for square and our walls for parallel. Well, today we've been going around and making sure that our sills all the way around the building are level. And you know, it really is pretty incredible, but they're close to perfect, about an 1/8 inch variation. But sometimes that's not true. You'll have to adjust these sills a bit. Simply loosen the bolt. Take a couple of treated shims, pick that sill up the desired amount. And this crack here gets filled with the dry pack. It's a dry concrete mixture. Now take a look at these bolts. They're within 1 foot of the end. That's the code, not only here at the corner, but also down there at the joint. And then every 6 feet, you need another bolt. Now it's important not to take these bolts for granted. They're what keep your house where you want it to be, on the foundation. The next thing I need to do is cut out for the girders that'll go in these pockets left here in the blockwork. I first outline the cut using a scrap of the girder material, and then I plunge cut very carefully with the saw. Plunge cuts can be made safely with both hands on the saw. One hand controls the switch, the other hand momentarily lifts the guard. It always helps to have 2 people working. In this case, Joe's going around marking all the girder pockets, and then I work my way around cutting them out. Here we're building over a crawl space, so Joe's stretching a dry line tightly across the building from girder pocket to girder pocket. Then he uses a scrap of girder material on top of the pier block, and he measures the length of each post. He marks that length on the pier, and I write it down on a cutting list. If you're supporting larger joists over a full basement, you'll find more information later on in the tape and, of course, in the book. With this cutting list, I can cut the treated 4x4s to length. One of the most efficient tools we have for cutting posts is a radial arm saw, but we don't have one on this job. So we'll be showing you several other tools. Here I mark the length on each post, and then I cross it off my cutting list. Here's another place I don't have to use a square to make a square cut. Just line that front edge of the saw up with the 4x4 and make your cut. There are other saws you can use to cut this 4x material. Here's one. It's a circular saw with a chainsaw attachment. It's got a guard here in the back, but it doesn't have one in the front. So when you're using this saw, set a square on the material, grab it with both hands, and use it in a safe manner. And here's another saw we use to cut heavier stock. We call it a beam saw. And then, if you have a power outage, there's no electricity left in the world, and your electric generator won't work, grab the old handsaw and go for it. And 3 days later, you'll be through this 4x4. Well, we've got all our posts scattered, and we're ready to nail them on top of our piers. Now this one here is in good shape. The post itself is cut square, and the pier is set in good and level. Well, let me tell you, I've been on a lot of jobs where this just wasn't the case. A lot of times these piers get poured out of level, and what happens is that makes the post out of plumb. Now, to compensate for that, you may have to cut this post out of square a little bit. So when you're finished, the post will set square on that pier and give good solid support to the girder up above. Now that we've got all these posts cut, we have to toe nail them to the piers using 4/8 pennies, 2 in from each side. You could also use 3/16 instead. And we just center them on the blocks by eye. Again, these posts are treated, but check the plans in the code to see if they're required in your area. The next thing we do is scatter and nail all the girders in place. Where the girders fit into their pockets, we cut a block of treated wood to bring them up flush with the sill, and then we nail them off. Notice that here in the crawl space, these girders are 6 feet on center. Over a full basement, we support larger joists by a girder or a wall in the middle. We nail the girders securely to the post with 3/16 penny nails. Now, in some areas, the code may require a plywood gusset or even a metal connector at this joint. Now, I want to show you something that happens out on the job. These piers, they're poured and lined, but let's face it, sometimes they're not done as well. So what happens is, when this post is put in the middle of the pier, you don't have full bearing under this girder. It looks something like this. So what we do is we nail both ends, and then later on we can put in these posts and line them up like they ought to be. So it has full bearing underneath this girder. Then we can nail it down. Another thing is that when these pier posts are 3 foot or longer, you have to nail a brace on them. That's what the code wants. Well, it's obvious that this post is only about, what, 20 inches long? But this is the way the brace nails on. Now, beams aren't always perfect. Take a look at this one. It's twisted. We want it to set flat down on that girder post. Let's show you how we do that. When a girder's as twisted as this one is, I just make a cut mid-span right over a post. That way the twist is taken up by two pieces rather than one. That's the way we want it. Well, we just have a few more middle girders to place. And to do that, we have to cut off some of the ends of the girders we've run in. We wait to cut them to length until after they're all nailed down, so we don't have to use a tape measure. Also, when we nailed them down, we made sure our nails were off to one side so the blade wouldn't hit a nail. You'll note that we're cutting to fit this building. We seldom have to use a tape measure. Here at the joints, we nail each girder to the post with 2/16, and then we join the splice with 3 more. Now with the girders nailed in place, Joe's taking a moment to sight across the top and make sure everything's flush. So I guess all these joists for this building are 2x6, huh?
Right.
Except in this front end where we have 4x4s for a deck that's going to be built out here. That'll drop it down 2 inches so we won't have water problems. And then I guess we only take 2 lengths, 16-footers and then 18-footers on over, except here in this area where we've got a little bay window. The cantilever's out 2 foot right there. It'll take 20-footers here. So I guess we can get started. Right along this side over here, we'll run on a rim joist.
Right, just use 16s over there for the rim.
16-footers here we'll use for rim joists. We'll get that nailed on, laid out, and pack joists. Let's do it. Well, moving lumber is one thing a carpenter does a lot of. Make it as easy on yourself as possible. Drop the lumber close to the building and learn to carry it on your shoulder. This is a rim joist. It nails flush with the sill. I nail it tight at one end and then toenail it every 16 inches with 16-penny nails. It's important to tie that rim joist to the sill. When you're framing up higher, you may need to work off the plate like I'm doing here. Now keep your mind on what you're doing and work carefully. The next thing is to lay out the rim every 16 inches on center to mark the joist locations. I use a crayon, we call it a keel, to make a clear mark at 16, 32, 48, and so on. The marks on the side of the line, these show where the joists will nail. Here on the garage slab, we've set up a model floor in order to illustrate a point. This rim joist is laid out just like the one we nailed on. We hooked our tape on the outside, came over 16 inches, made a mark for our first joist, then 32 inches, 48 inches, and so on down the line. Now, what this means is that when we sheet with our plywood sheeting, this first sheet is going to break half on this first joist. But that's just the way it does down there on our last joist. And it has to break like that because we're going to go on with another sheet. Now, traditionally, it's been done a little different. They'd hook their tape on the outside, and they'd come over 15¼ inches, make their mark. Then, they'd drive an 8-penny nail in at that point, hook their tape on it, and go 16 inches, 32 inches, 48 inches on down the line. What that means is that this first sheet of plywood will have full bearing on this outside joist. We don't do it that way. It means an extra step. And structurally, it just doesn't make any difference. With the rim nailed off, time to scatter the joists. Start on one side and lay down a joist every 16 inches. Once you get a few joists down, Then you have a safe walkway to carry the rest. Now we've got the joists scattered on one side, but they're long, so we mark them quickly with a framing square, cutting off the ends for blocks. These go between the joists. It's easier to work here in the middle of the building and cut these joists to length before we scatter all the rest of the joists on the other side. Once we get the joists cut to length on the far side, then we can scatter those that go here on this side. I push them up tight against the rim, cut off the excess by eye. Just make sure that your joists lap at least 4 inches. Okay, it's time to nail them in place. We roll them up on edge. Then we plumb them by eye on their layout marks. And then we nail through the rim right into the joists with 2 16-penny nails. And that's the code requirement. So we're rolling joists. That is, we're setting them up on edge and nailing them in place. Now, frequently, joists will have a bow in them. A crown is a bow. Common practice is to put that bow up. Then the weight of the building has a tendency to push it down straight. But in a building like we have here, we have girders every 6 feet. So crowning joists is not all that important. They're going to be straight once they're rolled. But if you do need to crown them, just sight down it and you can see the bow. As you nail, try and set up a rhythm. You can set a 16 with 1 lick or with 5, but it really doesn't matter. What matters is that you establish a pace that works for you, going easily from one nail right on to the next. Joists have to be secured not only to the rim, but also to the sill. 1 16-penny toenail on each side. Here on the other side, we're pulling our joist back so we can nail the rim on. We waited to nail this rim to show you how we do it when we're working on a second floor. Up high, it's safer to first scatter your joists and then use them as a walkway. Because we're at ground level, we can nail this one off just like the other one. Our building is 48 feet long, and we need several pieces of rim, so we just butt the pieces together. Now it's just a matter of nailing the rim to the sill, all the way around the building. Well, now I'm laying out the opposite rim. It gets laid out on 16-inch centers the same as the other side, but there is one difference. The joists here fall to the other side of the layout line. There's more on this later. Joe and I work together as a team, rolling, nailing off these joists. Joe nails out at the rim, and I'm nailing here at the center. The joists lap here over a girder. I nail the laps together, and then I put a block in between each pair, holding the block flush to one edge of the girder. It's important that these blocks are cut accurately because we don't lay out the center. We depend on the length of the blocks to keep our spacing just right. Hold on a second, Joe. I want to check our layout, seeing that we're running 4-foot-on centers. Yeah, it looks real good. Our blocks are the right length. Here in the middle, I nail in 2 16s through the joist into the block. Then lap the joists. The code calls for 2 more 16-penny nails here, plus a toenail down into the girder. Then another block. Lots of nails here. Away. Away. Nail. Here we're straightening the joists by eye before nailing them to the intermediate girders. Okay. Okay, away from me, about 1.5 feet. It got the crookedest joist in the city. Back to you now. Back to you. Nail that. All right, looking good. Way here. Nail that. Okay. Joe and I have been up on that main floor working, but now I wanted to come down on this model floor and show you a little bit more about layout and about how we nailed it all together. You'll notice that on each rim joist, we have a layout at 16 inches on center. The only difference is, here, the joist goes on this side. Over here, it's nailed to the opposite side of the layout. This allows these two joists to lap here in the center. Then, with a 13-inch block nailed in, we maintain our 16 inches on center. The block gets nailed in with 2 nails on this end and 2 nails in through that joist into the end of the block. Here at the lap, we nail this lap together with 2 16-penny nails. Then down into the girder, you get a toenail down on this side and another 16-penny toenail down through this side. And that's what happens at every girder. We get a toenail here and a toenail here, and at every cell the same. A floor nailed together like this one meets the building code requirements and gives you a good solid base on which to build your home. Now we've got all of our regular floor joists run in, 16 inches on center, but we need a few more to support the interior walls which run parallel to the joists.
Coming back 2/6.
Joe's finding the location of these walls on the plans and marking their center lines on the rim.
Going forward 4/3.
Now the actual joist will set 2 inches to one side of the center line. This will leave room for any pipes or conduit coming into the walls from below.
I'm done.
Then Joe feeds me these doubles, and I cut them to length by eye, sighting down the block as a guide. Since we nailed the blocking flush with the edge of the girder, these doubles have 2 inches of bearing. When the double comes in from the other side, cut a notch in the block so the double can bear right on the girder, but only cut deep enough to remove the notch. We don't want to weaken that girder. That's that one. This is an access hole for the crawl space, and I have to double up the rim here to support any load from above. Here we're working on our bay window, and that's why these joists cantilever out over the edge of the building. Because of that, we stopped our rim joist and ran in 14.5-inch blocks to maintain these joists at 16 inches on center. This bay window comes out from the building line 24 inches. So we measure out 22.5 inches, make a mark here, and another one down at the last joist. Then we'll snap a chalk line and cut it and nail on our rim joist, and we'll have a full 24 inches. You're right, some of these boards are ugly, but the discoloration is only on the surface, and it doesn't affect the strength of the wood. This is Douglas fir framing lumber, number 2 or better. It's strong, and as a framing lumber, it's hard to beat. You can see that I've let this rim run long. I'll cut it later. Now the front of the bay is 4 feet wide. I found the center, and now I'm marking the edges of the bay 22.5 inches from that center line. Next, I snap a line at 45 degrees to mark the sides of the bay. I have to lay the saw over at 45 degrees to cut the joists. The rims then nail on with a 45-degree cut on each end. A bay like this really makes a simple building more appealing, and it only takes a little more effort. I know it's hard to see, but I'm working right here in the middle of a bathroom. Now there's going to be some plumbing coming up here through the floor to serve as a toilet. Because of that, we had to cut out a section of this joist. We supported that joist by a header, and we used two different kinds of hangers, a U-type here and an R-type here. Framers prefer this R-type hanger because it only takes 4 nails, whereas the U-type hanger takes 5 nails per side. But what about if we need a larger hole in these floor joists, like for a stairwell, where we have to cut not only this joist, but maybe this one and several more? Well, if that happens, then you have to double up these side joists. Not only the side joists, but also the header joists. There's more information about this in the book. The floor frame's almost finished. We just had to add some more blocks to support the heating vents. Well, the heating contractor is finishing up their ductwork, and we're almost ready to sheet this floor. Let's take a look just for a minute at the underfloor ventilation. Here it's in the blockwork, but frequently we'll cut it in the rim joist. This is easy enough to do. We just cut out a section of rim between 2 joists. Then we can nail that same piece flush with the top to support the sheeting. Then a screen vent gets nailed in the opening. Crawl spaces need vents. A full basement may not. We've got all our regular blocks cut. Now we're cutting spatials. No need to use a measuring tape. Just shove a block in the hole, make the cut. A spatial is any block that's not a normal length, like here at the end of the building. On this section of rim joist, we had to cut out for 4x4s that will be used as joists here on the porch. After these are sheeted with 2x decking, the porch will still be lower than the house deck, preventing any water from running inside. We mark for the cutouts with a piece of scrap, and we make the cuts. Well, now we're ready to run our first row of 3/4 tongue and groove plywood, sheet this building. I came off the corner here 4 feet and a half inch. That leaves room enough for our 4-foot sheet of plywood, plus a 1/2 inch for the tongue that's going to lay to the outside edge. Now it's really important to get a straight line all the way down through there for our first row. To do that, we're going to use a string. Carpenters call it a dry line. We're going to pull that all the way down through there. I'll mark a couple times in the middle, and then I'll snap a chalk line. It isn't necessary to use a dry line on a short building. I'm using it here to show you how we do it if the building is longer than your chalk line. Just run out the dry line, mark the middle of the run, and then you can snap twice. This is 3/4 tongue and groove sheeting. It's strong, but your code may only call for 5/8 or even 1/2 inch. Here Joe and I are scattering an entire row out in front of us. We use construction adhesive for a couple of reasons. It bonds the plywood to the joist, and it keeps the floor from squeaking. We only run on a sheet's worth of this stuff at a time. This way it won't dry out. And on most joists, we can run a bead right down the middle. But where the sheet of plywood ends, I need to run it right on the edge. We flop a sheet over and nail it in place. We follow our building code and drive 8-penny sinkers every 4 inches along the perimeter of the building, every 12 inches in the field, and every 6 inches at the joints. Now your code may call for ring shanks or even screw nails. Plywood will expand in wet weather, so we leave an 1/8 inch gap in between those joints. We just stick in an 8-penny nail, then we're ready to nail it off. On longer runs, leaving an 1/8 inch gap between the sheets means the ends won't always break on a joist. Now when that happens, just trim a sheet or scab on a 2x to give the end full support.
19 1/4, 24 1/4.
19 1/4, 24 1/4. We've got the edge of this sheet of plywood right on the chalk line. Joe measures for the heating duct. You're right on the line?
Yes.
29 1/4?
40.
And 40. And then I mark it out. Got it. And then, with careful plunge cuts, I cut out by eye between the marks. That's pretty bloody incredible. I'm sorry I ever questioned your ability to measure. We're hand nailing on this floor for a while. Normally, we nail these floors off with a nail gun. But a lot of people don't have a nail gun, so there's no reason that you can't learn to be a fast nailer. Take a bunch of 8-penny nails out of your pocket. They come out looking like that. But you grab all the nail heads that are face down, pull them out, put them up. Then they'll look like that. Now you can finger those nails out one at a time. This is the way it goes then. I'm using a drywall square to mark a half sheet, which we position and nail down at the end of the building. You always want to stagger your plywood seams from course to course. So we start every other row with a half sheet. Tongue and groove plywood needs some persuasion. Right side. And it's helpful to have 2 people. Hit it, tap it. Joe uses a 2x beater block along the groove side of the plywood. The 1/8 inch gap between the sheets can be maintained by using a nail or by eye. Don't beat on that sucker too hard. Watch your endo. Okay. You got it, Joe. Looking good. Let's nail her off. We also have to cut out for plumbing pipes.
There we go. 45 1/4 center.
45 1/4.
Both of them.
Both pipes. That's the copper pipes.
Yeah, there we go. 31 and a half, 39 and 3/4.
31 and a half, 39 and 3/4. I'm just marking the centers of the pipe, then I cut around them by eye. Whoop, that's got it. That leaves an 1/8 gap. Well, it's nice to have help when you're nailing off a floor by hand. The small hammer works, as well as this pneumatic nailer, which speeds up the process. The plywood ends that overhang the rim are marked with the chalk line. And then they're cut all at one time. Well, we're almost done. We just have to sheet the bay area here. And again, we don't cut first, we cut later. We nail down a full sheet, 12 3/4, mark for the rim, and cut it out. Get the diagonal snapped here. Over just a bit to your right. That's got it. Go ahead and snap. And on a getter, just a couple more pieces of sheeting. This is a good place to use up all the scraps. Well, this cut here at the end of the building finishes the main deck. Only thing we have left to do is the porch. Well, at least it dried up enough that we can pack these cedar boards that Joe had cut at a local sawmill. Again, we lay the first board to a line so it'll be absolutely straight.
You ready?
I'm ready. All right, lay it on the line. You got to give me a little bit. Okay, I got about an inch here. Looks good. Let's. Okay. Then, because we're screwing these down, we drill pilot holes through the decking. Here I'm using a drywall square as a guide to keep the holes in a good straight line. Then I screw the boards down with a 3-inch non-corrosive screw. And here at the end, Joe snaps and cuts. Wow, it looks like we're finally going to get a break in the clouds and get a little sunshine on our backs. But in spite of all the rain, look, we got the floor all down. The deck out here we'll finish up after the exterior siding is put on. I want you now to take a look at this floor. It's a pretty typical floor. It may be a little bit different from the one that you're going to build, but let me tell you, the basics, they're the same. There isn't anything complicated about what we've been doing out here. It's just a series of simple steps that if you follow them, you can build the same kind of solid floor that we have here. Solid so that when you roll your grand piano out in the middle of this floor, it won't fall through. Anyway, we're ready now to get our lines down, put our plates down, and start framing walls. So let's do it. Well, as you can see, we've jumped way ahead in this building process. The floors are all down, got the walls built. Here we are, joisting on the second floor. But this is a one-story building. We put these joists up here just for demonstration purposes. We wanted to stop for a little bit and show you how to joist with heavier joists. In this case, 2x12s. Here we have a built-up beam, and we're putting on hangers. Now, it won't be long before we'll take all of these joists out of here and we'll get on with the building process, putting on ceiling joists, nailing in rafters. Out there on the outside edge, those joists are going to cut to length and we'll nail on a rim joist just like we did down on the first floor. Here you'll note, in this section, we left a large opening so stairs could come from that first floor up here to the second floor. These hangers can carry a lot of weight. Place them right on the layout and drive a hanger nail in every hole. Now, whether over a basement or second floor, larger joists are frequently used because they can span a longer distance and carry a heavier load without any support. One way to cut the joists to length is to snap a line on their top edge 1.5 inches back from the building line. Then just side down square and make the cuts. Finally, the rim joist nails on, just like the other rims. 2/16 into every joist. When your house has a second story on it, you have to build a flight of stairs. So we want to show you how to build a simple set of straight flight stairs, just like this one we have here in the small model. It's going to go right up here in this hole. It's called a stairwell. Now, to begin that process, you have to make a measurement. Hook your tape on the subfloor and measure down to the subfloor. It's 109 inches. It's really important to note that that measurement has to be from finished floor to finished floor. Now, we've got carpet throughout this building, so that measurement's going to work. But if you happen to have a real thick floor up there, and down here you had a thin floor, then you have to make some adjustments. There's a lot more about that in the book. Now, with that one measurement, 109 inches, we're able to calculate how many steps we need and how high each one of those steps or risers is going to be. Let me show you how we do that. To calculate the rise and the run of a set of stairs, we take the total rise from finished floor to finished floor. Here it's 109 inches. We divide that by 7. That's a standard riser height. That gives us 15.5. Well, you can't have a half a riser. So we divide 109 by 15 full risers, and that equals 7.26 or 7.25. Now, a common rule in order for a flight of stairs to be comfortable is that the rise plus the run should total between 17 and 18 inches. With our riser height at 7.25, a run of 10 inches, that gives us 17.25. That's right in the ballpark. Well, we know our rise and run, so we can set up our stair gauges on this framing square. Over here, 7 1/4 for the rise, and here, 10 inches for the run. This is the tool we use to lay out this stringer so we could cut out these notches. Now, you'll notice right here that this angle is not 90 degrees. We like to give it a 1-inch back cut right here, so this tread will be just a little bit wider. Now down here at the bottom there's something really important. We call it dropping the stringer. What that means is that we have to cut off of the bottom of these stringers the thickness of this tread. Well, the tread is 3/4 of an inch thick, so we cut off these stringers 3/4 of an inch. Now that means that all of these risers will now be the same height. One last thing, we notched our stringers like this. That allows us to put in this 2x4. We call it a kicker. Once that kicker is nailed down, it keeps these stringers from slipping forward. I start layout from the bottom, marking the first tread and rise with a square. Then I need to mark for dropping the stringer. I make a line representing the floor and then come up the thickness of a tread, 3/4 of an inch, and mark the cut line. Only this bottom riser needs to be shortened since it rests on the floor. I continue on up, marking out rise and run with a square, and I keep track of the number of risers as I go along. Now up here at the top I mark for the last tread, making it 1 inch wider than the rest. And square off the run from that point. You'll see why I do this in a few minutes. I've got a few more marks to lay out. Down here at the bottom, I come in 1 inch from the riser line I marked before, loosen my stair gauge, pivot the square to a new mark, and tighten the gauge. Now I can mark for the back cuts on each riser. But before I move too far, I also use a scrap of 2x4 to mark the notch for my kicker. And finally, I can saw everything out. I'm careful not only to mark accurately, but to cut accurately. That way I can use this stringer as a master template. You can see that on top here, I'm overcutting the intersection of my lines just enough so that the pieces will fall out. That way I don't need to come back with a handsaw to finish up. And to be efficient, I make all cuts running in one direction first, then turn, and work my way back. You can see how the cuts meet underneath here. The next thing I do is nail fences on the edge of the stringer. That'll help me to flesh it up with the other 2x12s, and I can use it as a template. Now you want to pick out good straight stock for your stringers. Boards free of any large loose knots. After marking, I cut the other 2 stringers the same way. Next I mark where the top of the stringers fall on the header. For the stairs in this house, I mark down 1 riser, 7 1/4 inches, from the bottom of the subfloor, and I draw a straight line. One way to support these stringers is by hanging them with these metal straps. Other ways to do this are shown in the book. Then I nail a block flush to the back side of the first stringer. It's just long enough to space the middle stringer dead center.
All right, hold on down in here. Hold him right there.
Got it on the line?
Yeah.
All right.
Hold him.
Holding the top of the stringer even with the line, Joe nails it in place. Then positions and nails the middle stringer. On the line?
No, it will be. Hold it right there.
I got her. 2/16 into the block and 1/8 through the strap. Now the last stringer, tight to the joist on the right. Then we measure and cut a second block to fit tightly between the two and nail it off. Down at the bottom, the kicker, cut to the width of the stairs, goes in. I flush it up tight against the wall, nail it into the floor. Center up the middle carriage and nail all the stringers down. It's time now to cut the treads and risers out of 3/4 stock. Here's one way to get a straight cut, by using a board as a cutting guide. You could, of course, use a table saw. And here's a riser being cut. I start at the bottom by nailing on the first riser with 8-penny nails. Once these stringers are nailed in, you need to check to make sure that none of them are bowed up or down. Take a look at here. This stringer's really high. So what we've done so far is nail in a riser board at the bottom to hold these stringers stable. But before nailing any other riser boards in, we want to catch this one. We want to make sure that these stringers are level all the way across. So we can nail it here on the outside edge. And Joe's going to help. Pull that center horse down so I can get this outside one nailed. I always choose straight stock, but when I was cutting this middle stringer, I could feel the tension release and it bowed. He's got it right on the money. Hold on, I want to get one more nail in that thing, Joe, to hold it down there. All right, that's got it. And now all I need to do is finish nailing off the risers. Now the treads. To prevent squeaks, you want to use construction adhesive on top of the stringers before you set the treads. That'll also strengthen the entire stair. You can either use nails or screws here. Just make sure to flush everything up first. Now there are different ways to nail on these treads. You'll notice that we cut ours flush here with the riser board. They're going to wrap carpet right up around that. But there is another way. You can let your tread hang over right here and you'll have a nosing. The last thing we need to do is nail in a 1-inch strip here at the top before we nail the last riser in place. You'll see why in a moment. Well, we're back here now on this model, and I want to show you something. You'll remember that we cut this tread right here at the top 1 inch longer than the rest of them. Well, we did that for a reason. The reason is that we wanted this last riser here at the top to angle back, just like this one angles back. Well, it was easy to do. We nailed in this strip of 1x, then the riser board. Now, look at the way it angles back. So now, every riser and every tread in this set of stairs are the same, all the way down. I've taught a lot of students, apprentice carpenters, how to build these simple set of stairs. And I think almost every one of them thought the stair building was really difficult. And then they tried it, and they found out this isn't so hard. All we have left to do to finish these stairs is nail on a few treads and risers.